while I'm getting this thing on, next month's meeting is not here. Next month's meeting is at Art Craft Moldings on the north side. I think it's on Spring Garden Avenue. By a show of hands, who doesn't know where Spring Garden Avenue is on the north side? Okay, we'll publish a map. And maybe you want to leave a few minutes early just because it can be a little confusing over there. I'll find out about parking and whatnot. Artcraft Molding has been there for a long time, unbeknownst to me. But I got a call from, let me think about this, the owner's father-in-law, who's an ex-advertising executive, and reading between the lines, I think he's trying to help his son-in-law take the business to a new level. They do molding work, and they're going to give us a full tour of the facility. I think everything from their rough mill area through their molders. So it'll be kind of a plant tour, as well as an opportunity to find a local source for moldings, for those of you that like to do things around your house that incorporate moldings. I think some of their stuff is furniture scale as well, but probably not in woods that most of you would be using to make furniture. So that's next month. Watch for the newsletter, not here. Okay. Any questions on that before I get started? All right, fine. So today, we're going to talk about making curved tail dovetails. As I put in the write-up, sometimes I'm obsessed with making things more complicated than they need to be, and I can't help it. That's just the nature of who I am. But I've always been intrigued by having unexpected shapes in unexpected places. Certainly people have made curved dovetails forever. Lots of times you'll see them on things like Bombay chest or anything with a curved drawer on it. But usually the pins and tails have straight sides on those. So, by way of example, Alex, I don't know, does that work?
Yep.
Okay. So, by way of example, and this is what a traditional through dovetail would look like. Oh, can you do that? This is what a traditional through dovetail would look like. We are not going to talk today about how to make dovetails generally, or we're going to talk about one very, very specific case of doing this. All I want to say about traditional dovetails and how to make them is there are, I don't know, countless ways out there that people make dovetails, from fully machine ways to fully hand-cut ways, bandsaw methods, table saw methods, hand-cut methods, etc., etc. All of those methods are relying on the fact that this line right along here is a straight line. So it's easy to cut with a saw, easy being a relative term. But that's what makes a traditional dovetail fairly accessible regardless of the technique that you're going to use. My complicating factor is to make the pins and tails curved on the side. How much curve? It's kind of up to you. This is roughly a 7-in-1 angle. There's you can read, people like 6 to 1, 8 to 1. Some want to go more, some want to go less. I don't care. I think that's much to do about nothing. Personally, that's about 7 to 1. I like the way it looks. The curve is subtle but noticeable. My design intent here is I want it to be discovered I don't want it to be in your face. I want it to be a subtle thing that's discovered as people begin to examine the furniture a little bit more closely. So that's why the curve is relatively shallow. Let me, you can get a sense, I don't know how close you're zoomed in, Alex, but you can get a sense of the amount of the curve. The amount of red that's showing above that scraper is the curve. So over that 1 3/4 distance, that's about a 1/16 of an inch worth of curve in there. It's fairly subtle. So that's where we're headed. I was going to start with showing you how to make it, but I've decided after having gone through this thing that it probably makes more sense to talk in a little bit more detail about the main tool used to get there. And let me just pull a couple things up here. The getting there, let's start with this. So there's a joint that I did last night. It would help if I turned it around, correct? There we go. There's a joint that I did, and like so many other things in my life, I waited until the last minute to do them just because so many things were going on. So this was cut last night about 7 o'clock. It works, and I did this with router templates that I made based on that drawing. So this is where we're headed by the end of the day today. It does fit, and I will pass it around so you can get a sense of it. It's a little tight, and that's good because we're going to talk a little bit about what to do about that. I want to point a couple of things out. One, on the back side of the tails, right in here, you're going to see that I have chamfered them to help the joint go together a little bit better. When you look at the inside of the joint, when it comes around, it will not look neat on the inside. That doesn't matter, at least it doesn't matter to me, because that joint will never be seen. This is not like a drawer where you see the inside and the outside of the joint. In my particular application, this is going to be the border of a table, and you'll never see the underside of the table. Were it something different, I would not have undercut it like that, and I would have spent a little bit more time fitting the joint. It's probably the case that you shouldn't have to pound a dovetail together, but again, having it be a little tight isn't necessarily a bad thing for this. Try this. Might as well get it really tight. Okay, so that's the dovetail that we'll be going for today, and I'll pass this around so that you can get a sense of the amount of the curve. I have left the tails long as well as the socket a little deep. I don't like to call it the pins. To me, I think more along the socket that the tails fit in, but that's just personal preference. Anyway, I've left them both long. After glue up, I would then flush these surfaces up for a nice looking joint. So let me start that around. And we got there with a bunch of router templates. So the question is, how do we get to templates like this from a drawing like this? And the key here is something that we've all heard about and we've all used before, but it's a special variation on it. This is a router guide bushing. And it is held into the base of a router. It passes through a hole. There is a threaded knurled nut that goes on, and it tightens. It is tightened onto the router base, and a router bit comes out of the middle. The way that guide bushings are used is that there's always a difference. Let me get a router bit. Probably not a great example. There's always some difference in diameter between the router bit and the guide bushing. And we've talked about that a lot in the past, but so I won't spend a lot of time with it other than to point out that is a traditional guide bushing. That is difficult to use to create a matching male and female pattern, because when you want to move the bit over and change change the relationship between the diameter of the cutting bit and the guide bushing, it's not an automatic sort of procedure. So there is something out there called an inlay or pattern making guide bushing. Alex, I'm going to have you zoom in really close on this one. So let's get a little pointer here. Here it is. This is an 1/8 inch spiral cutting router bit. That guide bushing diameter right there is 5/16 of an inch. That's analogous to the traditional guide bushing setup that we've talked about. This guide bushing has this collar which goes on, and this collar is exactly 1/8 of an inch, the wall thickness. So it adds 1/8 of an inch, or thinking differently, it indexes the router over by 1/8 of an inch. The fact that the wall thickness of that collar is 1/8 of an inch and it matches the bit diameter of 1/8 of an inch exactly allows you to index over exactly 1 bit diameter. So what that means is, in some cases, you're cutting using the, if you will, the inside, or in this case, this side of the router bit. And when you remove the collar and you move over against the same template, you're now cutting with the other side of the router bit. And that's what allows us to make male and female pieces that match exactly. I'll try to make that a little clearer with a couple of pictures and a demonstration. And let's maybe start with the demonstration. So, again with the curves, Bill, this is a butterfly template that you might want to use to put a butterfly in the top of a tabletop to reinforce a crack that might have occurred in the wood. In this case, I've made it with curved sides and curved ends. There's nothing special about that other than the fact that, again, I want something that looks a little bit different. Perhaps that would maybe be a bow tie more than a butterfly. Nakashima did them all the time, and they look like this. And I think the traditional method of doing them is to make the key, set it on top of the table, scribe around the outside, chop the mortise, route it to the correct depth, glue the key in, and you're done. And that's still a perfectly fine way to do it, but if you've got a whole boatload of them to do, or if your chiseling skills are a little suspect, or some other reason why you just decide you would rather do it with a router, then I'm going to show you a technique for doing it with a router. You don't even need to be thinking necessarily like this. This technique will work with almost any shape if you wanted to inlay things into the top of tables, cabinets, chests, whatever you want to do. So, I'm going to show you how to do the key first. It won't take very long, and then we'll move to the more specific case of doing the templates at hand. So let's pretend that this is a tabletop and this is some gnarly crack that you want to support. This is missing wood, let's say. So we're going to put our key right across there. All right, normally you would not screw this down to the tabletop, otherwise you've just created more problems. I've put screw holes in it just because it's going to be a lot faster to do it for the purposes of this demonstration. But normally when you make a template, you want to think ahead, make it large enough that you can clamp it, get from the, let's say you're trying to work something right in the middle of the table. You got to figure out a way to keep that template from moving. So maybe it's a long template that you clamp at the two outside edges and work in the middle. For our purposes today, we'll be able to use it like that. Yes?
Two-sided tape works real well too.
Yes, it does. And we'll get to two-sided tape in just a second here for the other half of this. So we'll just screw this down.
Have you found that those inserts sometimes are not concentric?
Yes. Calvin's question is, have I found that guide bushings in general are not concentric? That meaning, is the center point of the guide bushing the same center point as the router bit? And the answer is almost invariably no, it is not. The reason for that is because most manufacturers of routers, Festool may be the exception here, but that's a $700 router, so it can afford to be the exception. There's a lot of variability when you put a router together. There's variability between the way that the base and the motor attach together. There's absolutely variability between the way that the base plate is attached to the cast metal base. So if any of those have a little slop, and they do have a little slop, that's kind of the manufacturing requirement. Since the guide bushing is attached to this black plastic base, if it has moved a little bit, it will almost assuredly not be concentric with the bit. The way we deal with that is you hold the router in the same position every time.
There's another problem with those bushings too, that they're not always the same thickness from one side to the other, so that eliminates that problem as well, though.
That I have not experienced that, but did everybody hear what Calvin said? He's suggesting that some guide bushings are not the same thickness from one side to the other, the wall thickness, right. Correct? I have not experienced that, but I probably wouldn't have, because I'm religious about keeping the router orientation the same, and I'll demonstrate that in just a second. Yes, Jerry?
I ran into this problem. I had a DeWalt router that was off, and found out that they make basically for lack of a better term, a bit that's cone-shaped, and you put it in the router, loosen up the base, bring the base or the cone down to the base, and you can center it pretty accurately that way. I tried to get one for a Colt hound head router that size that you have, and searched all over the place to get one. Found out later that Lee Valley Tools has a nice tool that'll work for that, that's pretty inexpensive. You can use it with a guide bushing that's a small diameter, line it up well, and then use whatever guide bushing that you want. But it's basically a cone on one end and on a straight shaft on the other. It's like 5 or 6.
Is everybody understanding what Jerry is saying? If not, just look it up online. Guide bushing centering bit. That's what you'll find. They work. I don't own one because I'm really disciplined when I do things like this, and I just don't turn the router around. I've never found the need to, and if you don't turn the router, it makes that step completely unnecessary.
Right.
Not only am I disciplined, but I try to make money at this, and I try to not add extra steps to things that will just cause problems, or potentially cause problems. Wait, let's see here. Okay, so I need to think about this now, just for a second. Probably check my notes. We're going to make the mortise first. So, here is, where's my tape? Here's what we're going to do. Thought a drawing would help. Good there, Alex? So, the little red dot is my 1/8 inch router bit. And this particular application is using this collar right here, this 1/8 inch collar, which causes the bit to be moved over 7/32 of an inch from my template. So, this black line that I drew, I knew that I wanted a key about this size. That's where you see the hatch. So I made my template 7/32 of an inch larger. I mean, did I really measure 7/32? No. I just kind of drew a key about 1/4 of an inch bigger than what I thought I wanted, and that was enough. So when this guide bushing follows this template, it's going to cut where you see the hatched area, and notice that the bit is on the inside of the cut here, or of my line. So as I cut all the way around, I will define the outside of the mortise, and then I'll waste away the material inside. So let's do that first. Let me just set my bit depth here. This is the problem with these mics, isn't it?
Should be up in your shirt.
Yeah, it should be. But taking my shirt off would be ugly, so.
Take it off. Take.
This is not Burning Man.
Your loss.
All right, that's close enough. I'm not going to worry about getting it exact for the purposes of the demonstration. I should also say that this whole bushing thing will work with a template that is captures it from the outside, or you can have a template that is the shape of the key and work to the outside of it. I like using negative templates like this because in this case, I can't screw up my mortise. I can't pull the router bit too far in this direction and cause my mortise to get bigger than I want or sloppier than I want. My rationale for that is this. I got a tabletop. It's a $1,000 slab of walnut that I'm trying to put a mortise in to repair a joint. So that is something I can't replace very easily, so I make the template so that I can't screw that up. When I go to cut the inlay piece, you're going to see that if I allow my router to move off the edge of the template, I will have destroyed the inlay, but that we don't care about because the inlay, you can make 1,000 of them until you get it right. So, having said that, let's cut a mortise. Most people would use this with a plunge router. I'm not going to worry about that. I'm just going to, you'll see me take the router and just rotate it down into the work and then start going around. Normally I wouldn't stop, but since this is a demonstration, that's defining the outside of the mortise. You can, that little bit right there is just where I plunged in, but you can see that there is a nice 1/8" channel all the way around. So now I will waste out the middle. And in this case, wasting out the middle is something you could almost do with your eyes shut. Again, because the template is trapping the router, or the guide bushing, you can't go too far in the wrong direction. My personal thing, I wrote it on the other template, is DeWalt label always facing me. So that's what you saw me do there, and that's what you'll soon see me do all day long. Normally I would write it right on the template, DeWalt, and then put an arrow, so that if I pick up the template a year from today, although I would not be doing, I'll always be trying to match the mortise and the inlay at the same time, so it doesn't matter if I churn it a year from today, as long as I'm making both pieces turned in the same direction. If I was doing a lot of these, I would have probably another bit set up, a larger diameter bit, to hog out the material, especially if they were bigger than this. I've missed a few spots, I'll go back and get them right now. This is a solid carbide 1/8" diameter upcut spiral. It's probably about a $20 bit, maybe $10. More to the point, it's a little fragile, so you can't hog a lot of material, you just need to be careful with it.
Bill, have you ever experienced a screw effect on an upcut spiral where it wanted to pull itself out to chuck into the wood?
Yes. Tighten the chuck.
Yeah.
Fragile 1/8" upcut bit.
Yeah.
What's the maximum depth you would cut with that per?
Well, the maximum cut I can get is about 3/4 of an inch before it hits the inside of this guide bushing.
Okay, and then how about per single pass, per each 1/8" increment?
I'm going to do the templates, cutting all the way through. Sorry. Cutting all the way through 3/8 Baltic birch plywood, which is nominally about a strong 5/16 of an inch thick. So it's a brand new bit. It's really sharp, so it does that without any real problem. Yes, John.
In line with what he was asking, if you do start trying to do it in multiple steps, you end up introducing a lot of extra slop because as the router rotates.
It's possible, John. I have not done it in multiple steps, so I can't answer that question. But Actually, when we do the templates, you're going to see another technique that I use that I really only care about the top 1/4 inch, because after that, if I need to go deeper, I'm going to use a different router bit that references that portion that I've cut, and that second router bit is dead flush between the router, the cutting edge and the bearing that references it. I just have one little spot I can see here on the corner that I need to resolve, and then I'm done. Okay, so mortise is done, except for squaring the corners, because it's a round bit, which will, in this case, since it's an 1/8 inch diameter, it is making a 1/16 inch radius round in each corner. You know I'm going to lose those, but... So Alex... Here's the mortise, there's the round corner right there, right there. So let's do a quick chop. And I should probably have a slightly narrower chisel than this, because the curve at the top of this key is tight enough that with this 1/2 inch, do I have a 3? No. With this 1/2 inch chisel, I can't get all the way into the corner, but you guys understand. And
Do you have to take out the radius, or would the butterfly be radius on the other part?
the butterfly will not be radius, because you're cutting around the outside of it, and whenever you cut around the outside, you get a square corner. So no. Although you could radius the key to fit this, but it's already machine made. Why make it screen machine made? It's so much easier just to square the corners, and then it looks like you were just incredibly neat in your ability to chop a mortise by hand. And like so many other things related to mortises and dovetails, you can undercut the corner, or you can undercut any of these, because you're not going to ever see that undercut. So you notice my chisel is not square. I'm actually undercutting just a little bit like that. And again, this is purposes of demonstration, just trying to fly through this. You can spend as much time as you want getting those mortises square, those corners square. I overcut one corner a little bit because I shouldn't be talking, I should be concentrating, but anyway, it's close enough. So that's the mortise. Now let's talk about how to make the inlay. So in this case, we're going to have a nice MDF inlay. Normally you would take, I don't know, let's say you'd want a walnut piece on here. So this mortise is a 1/4 of an inch deep, just under a 1/4 of an inch deep. That's good because that's 1/4 inch MDF. So you take a piece of wood and mill it to just slightly thicker than the depth of the mortise, and then you would make your key out of that. So I didn't feel like doing that, so I'm just going to make the key right here. Since I'm going all the way through, I have a sacrificial board on the back side. And Mike talked earlier about using double stick tape. Double stick tape is important to use when you're making the key, because after I've routed around the outside of it, after that last bit of material is released, the key comes loose, and the last thing you want that key to do is vibrate into the turning bit. This will make a little bit more sense as soon as, let's see, I'm going to do it here. Okay, double stick tape. It would help to know where it is on the other side. 4 3/4 to 6 3/4. Okay. So, clamp that down, get our template, put our template roughly over the same spot, and thank you. Screw it down again. Okay, so here we go again with my typical speech. Your personal safety is absolutely your responsibility, notwithstanding what the courts have said about table saws. 2 clamps. 1 clamp, that piece is going to rotate one day when you're least expecting it to rotate. You're either going to follow your work or you're going to follow your hands. 2 clamps. Your responsibility. Okay, so here, the plunge router would be much more helpful, because what I need to do in this case now is I need to remove that collar to move over that 1/8 inch diameter, and let's put up this drawing right next to this one so you can see where we're going. So, now, there's the router bit, same red dot. The offset is the same 7/32 of an inch, but notice that because the router bit has moved this way 1/8 of an inch, you can see how this one is closer to the edge of the template than this one. We are now cutting on the opposite side of the bit, and the hatch mark is the path of the cutter. What's in the middle is the inlay, and that needs to remain pristine. So if I allow the router to move off the template, I'm going to foul the inlay and make it unusable. So I need to be very careful that I keep the router pulled up against the outside of the template for the entire pass. That's a little difficult to do when you're just trying to tip it down into the work. So that would be the case where if I was using a plunge router, I'd simply have the router up, push the bearing guide against the side, plunge, and start my cut. But I was a little lazy last night to set that up, so we're going to try it like this. if my foot was set deep enough, I hope it was, we've gone all the way through. Well, I'm a fraction not deep enough. You can see the little lip that's left there. But it doesn't matter. Shouldn't say it doesn't matter. It matters. So let me keep this orientation the same too. This was this way. I was doing this more for purposes of demonstrating the use of that collar. So,
Pocket knife?
you would probably chamfer the bottom of your inlay anyway. Let's see. I had that that way, I had that that way. Perfect inlay. So, and now you can fight Mother Nature. That crack will never open up. Well, it shouldn't open up beyond that point. Keys and tabletops don't need to be that thick. I think Nakashima's work, they used to go maybe half the thickness of the wood. The deeper they go, the harder they are to do well. I can see the little corner where I missed in squaring the corner, but anyway, that's the beauty of that matched set. So, one template, male and female, mortise and tenon, mortise and inlay, whatever way you want to call it. Yes, sir?
Can you quickly give a synopsis recap of making the positive?
Sure. What, you mean this?
No. After you took the 8-inch bit,
Oh, okay.
as you call it, can you quickly recap that one? Beyond that, when you made the, when you got to the point where you put the double face tape on?
Sure. I'm trying to think of a different way to do.
Just with what you did with the bit and the collar.
Okay, so looking at the picture again then. Let's try it like this. So here we are with the 1/8-inch collar on, which is here. So if we're looking at the template, you see how far the bit is away from the edge of the template. Can you see that?
Yes.
Okay, and that's this drawing here on the right. When I remove the collar, it moves the bit closer to the edge, and that's this drawing here.
All right, so there's still the collar that went on, the collar that you got receives the collar, so it just handles the difference.
That's exactly correct.
Perfect.
And the collar wall thickness is exactly the same as the bit. 1/8-inch collar wall thickness, 1/8-inch diameter bit. That's the secret here. It's moving it over exactly 1 bit diameter.
Thank you.
Okay. All right, so that's the generic example. Now let's look at the specific example of making the curved dovetail. Yes, go right ahead, Kelvin. So let's get rid of these for now. Okay, so, you all know where I want to go, because I've shown you that dovetail coming around, and you saw the drawing in the newsletter. But I'll put this drawing here, just so we always have it in mind. So,
A little closer
because-
together, Bill.
Closer together?
Yeah. Yep. All right.
Good?
Good.
Okay. Because these tails are relatively narrow at the bottom, and because of that 7/32 offset, in order to use this bushing, the template necessary to create tails that are 5/8 of an inch wide at the bottom ends up looking fairly extreme. And by that, that's what I mean by extreme. Now I'm going to hold that on here, and in this case, the red hatching is how far I had to move over from my original template. So what I mean by that is, you know, I put 3 pencils out, and you'd think,
Under the mount.
sorry. So this line right here is where I want to be. That red hatch is moving over 7/32 of an inch, and the green is ultimately what this template is going to look like. And there it is right on top. So that template is my starting point to create a male and female template in order to make the pins and the tails. I made it out of plywood because clearly this is going to be very weak right through here. Even out of plywood, Baltic birch plywood, these guys still flex a little bit back and forth. But that's why I've got screw holes in them so that I can screw them down so that they won't flex when they're being routed. So I made the tail template first. There's the tail template. And you can see, and this was made because my intention is that I'm going to make these tails and sockets with a router bit that has a bearing that's exactly the same diameter as the router bit, and I'll show you that in just 1 second. So you can see that that fits over the tails exactly. So that was my goal, to make a template that matched my tail boards exactly. That router bit, and this is essentially the key to my system here, that router bit is this one. It happens to be a mortising bit, but that doesn't make any difference. A mortising bit is just relieved in the center to help clear chips. More to the point, it's exactly a 1/2 inch diameter cutter, and on the shank is a 1/2 inch diameter bearing. So the edge of this bearing, I'm going to tilt it like that for you, Alex. The edge of this bearing is exactly in line with the edge of the cut. Exactly in line. So if I can touch this bearing to that template, let me do it on the outside where you can see it a little better. Touch the bearing to the template, the cutter is going to give me something that looks exactly like the template. Everybody got that? The bits like this are common, but usually not in a 1/2 inch diameter. They're often referred to as pattern maker's bits. Here's one that's a 3/4 inch diameter, 1/4 inch shank, 3/4 bearing, 3/4 diameter cutter. Again, the same exact flush condition exists. This one, the bearing is held onto the shaft by a little circlip here that you need special pliers to remove it. Eventually these bearings wear out and you can replace it. That's one technique. Here's another technique. Same diameter, 3/4 inch, same bearing, 3/4 inch. In this case, the bearing is held on with a little stop collar that has a little Allen key in it. This is by far the more common way that you see these things. Rockler's probably got them both up there. This is a Freud bit. I don't even know what flavor this one is.
One better than the other?
No. I like Freud bits.
I mean the design.
Oh, design-wise? This one's probably easier to get off. You don't need the special circlip pliers to pop the circlip off of it. Typically, for pattern bits that many of you are used to, the bearing is on the tip instead of on the shank end. That possibly can work in our situation here, but it's not nearly as user-friendly, so I'm just showing you that by way of comparison. This bit, while not a flush trimming bit, it happens to be a 1/2 inch diameter bit. Notice here that that bearing is just pushed onto the shaft. That bearing is a 1/4 inch ID, so it goes right over the shaft, with a 1/2 inch OD. You can take those bearings and push them on the shaft and generally not even have to use a collar to hold it in place. It'll just stay there by friction. If the bearing isn't lubricated well and you start to get a lot of resistance in it, in fact, if it were to seize, then you'll find that the ID begins to turn on the shaft and the thing can and does move. The way that we always deal with that is if we're using one of these that doesn't have a stop collar to hold it in place, like that stop collar right there, then we're sure that when we chuck it up in our collet, we chuck it up like this, if my fingers are the collet, so that even if the bearing were to move, it can only move up the shaft a little bit and can't leave the touching the template, which is what you're trying to achieve. Okay, so point here is this. Buy yourself a 1/4 inch ID, 1/2 inch OD bearing, slip it on the shaft of your router bit, and you can make your own pattern router bits. And that's effectively what this guy is right here. That's nothing more than us putting a 1/2 inch bearing onto a 1/2 inch cutter. We have used the stop collar. I don't want to take this off. Well, why don't I want to take this off? I'll take this off. Wait a minute. Yeah, this is set to a different depth, so. There is the stop collar, and Alex, since that camera is so doggone good, if you really zoom in, you can see the little Allen screw in it. And this stop collar is holding that bearing up tight against that cutter. And that's the secret of this system. Okay, so that's the tooling. I'm not going to pass these router bits around. I think you all get the point, but if you want to, you can come up and look at them after we're done. So, so now we're going from this template to here. Before we do that though, how did I make this template? Well, I took this, my drawing, which I did in the computer. You don't have to do it in the computer. You can just draw it by hand and go photocopy it if you want. You know that it's going to change size a little bit if you photocopy it. If you can have the ability to draw it in the computer, you can print as many of these out as you want. And all I did was shoot some spray adhesive on the back of it, stuck it down to a piece of wood, cut it out on the bandsaw, and I was done. Makes it sound so easy. It's not quite that easy. But anyway, so I took my original drawing and I put new lines on 7/32 of an inch over to create this. Then I cut all of this out. Now, I'm not going to actually cut them all out because that's not the point here. But these shoulders right here, that was nothing more than setting a fence on the table saw, using a miter gauge and cutting it off. Now I have two nice clean square shoulders. Then this one in between, you have to be sure that this one is exactly in line with these. That takes a little bit extra work. I bandsawed it close, paired it with a chisel. These cuts right here, I bandsawed very, very close and then finished them. Several ways you can finish it. You could sand it. You could go right off the bandsaw. I happen to use this. I'm not even sure why we bought this tool. We bought it once we had some big job to do a lot of little inside sanding, but it has proved absolutely invaluable for little things like this. Alex, I'm going to show you that there. So that belt, you can just touch one edge of it and just a little bit like that, a little bit like that. You can even get in there and clean that up. Sometimes it's fair to say that I design around our tool's capabilities. So I knew that I had a 1-inch sander. I knew that I wanted this to be at least 1 inch in there so that I could make it clean. I won't call that a tail wagging the dog sort of situation. It could be, but we have so many tools and such a wide variety of tools that it has rarely proved to be a limitation. Point is, be aware of what you are able to do tool-wise before you actually make designs that you can't execute. It could be executed just by chopping it by hand, and that's fine. And in fact, I did chop these inside corners by hand. So that's in general how I got to this template. Once I have this template, I need to make this template. So we have a bunch of blanks that are all the same size. So I lined it up. Alex, I'm just going to let you kind of focus in on here real carefully. Clamped it. Screwed it down in 2 steps. Again, I'm just making templates, so screwing them down is no problem. So these 2 screws are holding the main template in place. Zoom way in right here on this little bit here. Watch what happens. See how I can move that? So I can move that? That's a problem. So, does everyone know what a VIX bit is? Who doesn't know what a VIX bit is? Enough hands, okay. So, a VIX bit, these are bits that are designed to be used to drill a hole exactly in the center of another hole. Often used when hanging hinges with a countersunk hole. You notice here on the tip of this that it is chamfered to nestle nicely into a countersunk hole. And when you start the drill and push, this collar recedes and the drill bit comes out the end. That drill bit is exactly centered in there. So, if I take this guy and just touch it like that, and touch it like that, I've put two little starting spots right in the center. My screw is going to find that little hole to start, and that screw, as long as I hold my drill straight, will screw these down and they will not flex. Yes, David?
Is that VIX?
VIX. I think that's a brand. I don't know generically what they're called. We just call them VIX bits. They come in probably 3 to 5 different sizes. The size change being the diameter of the drill that comes through. How much it comes out, let me do this, is adjustable so that and you adjust it with this set screw here, so that your screws that are going in it drills a nice pilot hole for, in this case, I think a number 6 screw or something like that.
They make center punches similar to that.
They absolutely do. They make center punches that work exactly the same way. From a practical standpoint, we are often putting a screw in longer than the amount that this bit comes out. But once you've got that center spot there, then you can take a regular drill and just drill that pilot hole as deep as you want. Just want to be sure that it actually went in deep enough. And then put the 2 screws in. Okay, so there's the template, and then we would use the router and just route away the excess to turn this solid board into that template. And I don't think I really need to do that. I mean, I think you all understand exactly how that would work. One little tip I will give you though, and that is that, again, to lighten the load on the router bit, what I would typically do here, these are faster. What I would typically do is, I just happen to know that if I draw a line 1/4 of an inch away from that template, I'm going to be right up the middle of where that 1/8 inch router bit is going to go. So I just have a little 1/8 inch, I'm sorry, a 1/4 inch. I have a little 1/4 inch piece of wood here, so I'm just going to use it like a scribe. I'm putting a little line on here. I'll show you in just a second. You can see the lines I've drawn. Those lines are the bandsaw on. So I walk over to the bandsaw and I cut away all of this material here, all of this material here, all of this material here, and now my router bit isn't working nearly as hard. I'm not trying to mill an 1/8 inch wide, 3/8 inch deep groove and torque that bit too much. Instead, I'm just removing probably a 1/16 of an inch of material. So whoever asked the question about how hard I'm willing to push those bits, a certain amount of that is a function of wasting away material first. Okay, so before I go to the next one, any questions on how to move from here to here? Okay, so that's the tail template. The socket template or pin template incidentally, by a show of hands, how many people have to think about which half of the joint is the tail? Always? Okay, so I guess that looks like tail feathers, tail feathers on a bird, right. So anyway, okay, so there you go.
Or a fish.
What's that?
Oh, more like a fish now.
Well, yeah, exactly. All right, so now the here it is. So that's this one. That's what we just did.
Yeah.
So we cut away the red hatched area, leaving the tails. Now we need to do the sockets. And this one was not at all intuitive to me. So we're cutting away this area, leaving all of this area, trying to get to something that looks like this. And my first effort looked like this. So I cut the wrong part off. And I told you I would save mistakes, and there it is. And the reason I kind of discovered afterward why I did that was because looking at the drawing
Behind.
yeah, I'm looking for one more that doesn't have anything on it, but I'm not going to find that. It just, effectively what you have to do is you have to cut across here. And that just didn't feel right. Where's that thing? It just didn't feel right on the bandsaw to cut across there because, oh my gosh, I'm cutting the tail off. Well, yeah, that's the whole point. I'm cutting the tail off. So I made it twice last night. But anyway, that's kind of why it's always about thinking and thinking again and then thinking one more time about it. And I know exactly what I was thinking about when I did that. I was thinking about what we're going to have for dinner because my wife was out of town, she was getting home late, and we were trying to figure out if we wanted to go out or not, and that's what I was thinking about instead of this. So, bad idea. Okay, so anyway, how do we get there? We take another blank, and the template, screw it in place exactly the same, and just use the router bit with the collar on or off. I can't remember which way it is, but in this case, we're cutting along the edges, and this is like cutting the inlay. That is, the router bit has to stay tight to the edge. You just follow it, and then back it out, and then you cut it away after the fact. Because effectively, by leaving that piece, this piece, and this piece, and this piece, those are the inlays that fit inside of here. It's kind of weird to think about it like that, but by cutting away this socket, when we route on the end grain of the board, this piece, and this piece fill in that void, and that void. So they effectively become inlays. Where is that dovetail sample, please?
Here you go.
That one. So let's knock this apart and cut these, and we're done. No, I did plan for this, kind of. Yeah, plan for it.
Vice time?
Yeah, it's all right.
Dinner was better last night.
Yeah, we stayed in, so. Thank you, Kelvin. That's probably a little tight for a dovetail, and we'll talk about how to adjust that. Okay, so cutting the tails first. Tail board. Okay, where's my tail template? That's it there. Tail template. So it's a matter of lining everything up. And I've made the template wider than the wood so that I have a reference out here to start my bearing on before I actually engage the wood. So what I'm trying to do is basically get it centered on the wood and parallel.
Could you attach a fence underneath?
Absolutely, absolutely. Dick asked if I could have put a little fence along the side of it, and yes, not only could I have, but I should have. It just, if I was doing more than one, I would do that. So, I now have tails lined up exactly with the edge. As it turns out, this end is not the critical end. It is this end that is the critical end. And now it's time to route these.
You're going to a thinner stock than you originally planned?
Yeah, just for purposes of, geez, I can't get away with anything, can I?
What was the question?
Jerry asked if I'm using thinner stock than originally planned. The original drawing shows 1 3/4 and 1 3/4 inch material, and that's ultimately where the table will go, but it's much easier to demonstrate and cut through something that's only 7/8 of an inch thick.
You just put the wrong drawing in, Bill.
You need something under that, Drew?
No, I'm not going all the way through. And that's exactly what I want to demonstrate right here, right now. So, in this case, because this bit is short, Alex, you can see that, this cutting length on this bit is only, I think, 5/8 of an inch long, and I have to have the bearing out from the base enough that the bearing actually engages the template, so I'm not going to be able to cut all the way through. So let's go ahead and do that cut, and then go to the second step. I should also say that normally I would have wasted this away first on the bandsaw. I would have just drawn a line, cut it away so I don't have to route so much. Now, I'm not going to do them all. Here, let me,
Muhammad will come
that's
to you.
good. Yeah, Alex, if you want to come around like this for a second. I'd like to not change the relationship between the template and, can you see that? So, that router bit cut perfectly flush with the template. Can everybody see that? Okay, and it also cut flush up here. It obviously burned because that's end grain and because that bit is dull. That bit needs to be sharpened. As soon as I sharpen that bit, it is no longer usable for this application because it will change its cutting diameter from a 1/2 inch to something less than 1/2 inch, and therefore it'll not match the bearing. So for this application, it's shot, just throw it away. But it could be used for a lot of other things. So I have, before I take this away off this template, it would be very nice to use the template to guide my chisel to chop these corners square. So I'm going to do that. And that. And if your chisel is sharp and your wood is poplar, no problem. We'll also pare in this way just a little bit. Now, if I had a longer bit, and then I put a spoil board underneath, I could have cut all the way through, and all that groaning and everything that you heard was largely because the bit is dull, and even though these little laminate trimmers are great, they probably are only effectively 3/4 of a horsepower. That's a lot to do with a 1/2-inch diameter bit, but these are workhorses in our shop. We don't consider them laminate trimmers, we consider them routers more than anything. So that's the cut, and the only thing I wanted to show you, I'm not going to cut them all, the only point I wanted to make is once we remove the template, then we take the router, and you can see now the relationship. The bearing will reference the area I just cut, and the cutter will reach the rest of the way through the work to complete the cut.
How do you do that center part where the bearing won't fit?
You chop that by hand. Kelvin asked, how do we do the center part here, where the bearing won't fit? So you start in here, and you can get about that high. And then the rest of it, just chop it by hand. Okay? All right, so those are the tails. Do I need to demonstrate it, or does everybody accept the fact that now I can just step down deeper in that hole?
Yeah.
All right, so that's the tails. The sockets or the pins are done a little bit differently. We make our template using the same techniques that we talked about. I'm sorry, I forgot one thing. This is actually really important. This is a change that I will have to do before I go into production on my table. This one's a little weird. You got to kind of think a little bit about the geometry of it. Okay. So, I think I can demonstrate it right here with this bit. This template needed to be longer than the workpiece because as this bit is starting to come up this template, are my hands out of the way enough, Alex?
You're okay.
All right.
Just stay there.
So as that bit comes up there, as soon as the tangent point of the bit gets to that corner, it starts to walk around that corner. And anytime you have anything on an angle, 90 degrees this wouldn't be an issue, but because it's on an acute angle, the geometry is such that it starts to walk around the corner and it actually clips off a little bit of that corner. So this tail template needed to extend past the end of the board by probably another 1/16 of an inch, such that where that begins to go around the corner, that rounding over effect would not occur. It would be beyond the end of the board. It probably doesn't make any real difference in this application because the amount that's rounded over is past the end of the board enough that when I sand it flush, it probably will not show. Or I just go to 1 11/16 inch thick material instead of 1 3/4 inch material, and problem solved. But just like I took the template and made the template larger than my stock, you can see that right here, I should have done the same thing right there. So again, another discovery halfway through the process. That's why we do prototypes first. In fact, it's always a good idea to have templates when you're using router bits and bearings be on the side of your work so the bearing can engage on something before it actually gets to the work. It's just a more controlled cut, and in some cases it's a safety issue as well. All right, so that's that. Sockets. So we made the template, and the socket is done on the end of the work. So in this case, we need a way to hold the template to the work, and that's a fence. So that's the relationship, just like that. And it simply is clamped on, and then we route in like that. And I will do that one for you right now. I'm just going to estimate the center point here. You know, I have a tape measure. Jeez. Okay. First. So, key here is get your coffee out of the way. Keep the clamps where the router bit isn't. That's ugly. A lot of times I'll put one on in this direction first just because it's easier to use it. Hold the work in place. Switch it. I hate having to work around clamp handles, so I'm always fussing with keeping them on the back side of work if I can. And then this one, the router bit needs to be set to come to the requisite depth. And again, I can't reach down that far in one pass. So I'll simply route this out like this, lower the bit, do it again, and we're all set. I'm only going to do just one quick thing here just to demonstrate one aspect of it, and then we'll move on. So in this case, this is what we're doing. I'll turn this around for you, Alex. We're routing this outside face, which is the show face. So that edge right there needs to be really crisp. So you want to be sure that when you're doing your routing, as you go across that face, you're doing a climb cut so that you can score that face really nicely, and then you waste away the rest of the material into the cut. The outside of the socket is done just fine. It comes, actually, a couple things here. I'll come back to this little look in just a second. This inside end of the socket, again, when after the prototype, I'll make this guy go a little bit deeper right here, because you can see I've got a little bit of a rounded corner right there, even though this fence is farther in this direction than the backside of this piece of, the backside of my stock. It's not far enough that the radius of the bit would clear the back edge. So when I take this apart, you're going to see that I'm going to have a little bit of a curve there and there that I'll have to chop by hand. This look here is, Alex, zoom really close, but you can see my curve coming here, and then you can see it moving back in this direction. This was a result of that same sort of radius geometry problem, because my original template wasn't long enough. So instead of this curve flowing out perfectly, I got a little bit of this straight spot. So when I look at this piece, I'm going to see that, that this curve comes up here and then flares back this way a little bit. I should have just taken the template and just cut that off by hand, either by paring it or sanding it, but I didn't do it because I wanted you to see the problem that I ended up having there and why extending the template a little bit is necessary. So remove the template, and you can see a little bit right there that didn't get cut, and you can actually see a little bit on the tip right there. So that's just a matter of back in the vise and a quick pair. And the same thing on this outside corner. If there's a little bit there, there is. That one I want to be really neat on, because again, that's my show surface. And that's the socket. Now, of course, I haven't done the second step, and that is, once you've defined both of them, then you take the router bit, set the depth so that you reach down to the 7/8 that you want, let the bearing be guided on the cut that you've already made, increase the depth of the socket, and the job is done. Now, we talked about the fact that this joint is a little tight. And all we have to do to make that joint get a little looser is, and I need to think about this every time I say it, we need to effectively, there's two things to do. Right now, since this joint is tight, I could just take this side of the board and just take a couple shavings with a plane or some sandpaper or whatever to effectively allow this piece to move farther in this direction. Effectively, or stated differently, this wedge moves a little bit farther out in the socket and gets loose. So once we've done the prototype and we found out that it's a little tight, all we have to do is take our template, probably put on a piece of masking tape, which effectively moves it in that direction, which is the same as taking material off this side, and try another one. It only takes a couple minutes. You can just dial it in with masking tape or shims or whatever you want until you get the fit you want. It's incredibly repeatable, and then they pop together without any real problem. So, cut the sockets, cut your tails, cleaned them up, relieve the backside a little bit, and you know, if I push it together 2 or 3 more times, it might get loose. And you've all seen that. So, that's how I would make a curved tail dovetail. Questions? Finished by noon too, Frank. Any questions? Thank you very much. You're welcome to come up and look at anything you'd like.
Thanks, Bill.
You're welcome.
Okay, before you go away, we got a raffle.
Oh.